Hello, today we are working with 11.3, use normal distributions. There is a section in our textbook about normal distributions, but we decided to use a supplemental resource for this lesson instead. So you'll be finding the information for this lesson and the practice problems on Google Classroom from a packet. So our only learning outcome for today is to use a 68, 95, 99, 7 rule to approximate probabilities in a normal distribution. So in our packet, you will find some additional information that we are not going to cover today. So just focus on the part that talks about the 68, 95, 99, 7 rule. So normal distributions. We know that a normal distribution is modeled by a bell-shaped curve called a normal curve. So we looked at these earlier a few weeks ago when we talked about shapes of data. We talked about symmetric distributions, and one of those would be a normal distribution. So normal distributions can be good models for some real distributions of data. Some distributions that follow a normal curve would be scores on a test taken by many people, such as the SAT exam or IQ tests, repeated careful measurements of the same quantity, like the diameter of a tennis ball, characteristics of biological populations, such as the length of crickets or yields of corn. All of these sets of data would follow the normal distribution. So how do we use a normal distribution to find different probabilities with our data? One way is to use the 68, 95, 99, 7 rule. So the thing that you need to remember about this rule, and with all normal distributions, is that the area under the curve is equal to 1. So if we think back about probability and percentages, we know that they always have a maximum of 1 for probability, or 100% if we wrote our probability as a percent. So the maximum value under our curve is 1. So in any normal distribution with a mean and a standard deviation of sigma, we know that 68% of our data values will fall within 1 standard deviation of the mean. So if our mean is here in the center at 0, 1 standard deviation below would be indicated by this sign, 1 standard deviation above would be here, and that would account for 68% of our data. 95% of our data will fall between 2 standard deviations of our mean. So it would go from the -2 to the +2. All of that would be 95% of our data. And then 99.7% of our data will fall between 3 standard deviations of the mean. So the majority of our data is within 3 standard deviations of the mean. And then we have a tiny little bit left over that does not, that is not included in that. So that's that 0.3 you have left over that will be outside of those 3 standard deviations. So how do we use this rule? Let's go ahead and break down those areas and the percentages to see how this can be useful to us. So we have our normal distribution. I have different colors for the different areas. And this reddish pink area, remember, is 1 standard deviation away from our mean, and that accounts for 68% of our area. So if we wanted to find the area of each portion, we could just take 68% and divide that by 2. So we would get each area equals 34% of our data. Now for the next area, we know that this is going to be 95% of our data. So it goes from this line all the way over to this line. So to find out the purple areas, we know that we can take 95%, subtract the 68 that we just used, and then that will be left with our purple areas. So we can take that purple area, that 27%, divide that by 2, and we get 13.5% for each of those purple areas. Now, if we move on to the green, or the 99.7%, we know we can take 99.7, which again is 3 standard deviations away from our mean, and we're going to take away the part that we just found the area of, so that 95%, and we're left over with these little green pieces. So that's 4.7%. If we divide that by 2, we get 2.35 for each of these areas for our green space under the curve. And then lastly, we do have that little sliver on either end. Remember, our whole curve has an area of 1 or 100%. So if we take 100% and we subtract the 99.7, we get 0.3%, 0.3%. We divide that by 2, and we're left with our 0.15% for our area on either side of those little slivers. And so the reason why this is useful is, given the data and our information, we can find the chances that our data will fall within these little categories. So we'll go ahead and look at an example so you can see a little bit more how to use the 68, 95, 99, 7 rule. All right, so we're gonna go ahead and look at a data set about the cholesterol levels for 14-year-old boys. And as it happens, that this data can be modeled by a normal distribution. And the data has a mean of 170 milligrams per deciliter with the standard deviation of 30 milligrams per deciliter. So we're gonna let X be the cholesterol level of any randomly selected 14-year-old boy. So the first thing you always want to do when you're working with the normal distribution with your 68, 95, 99, 7 rule is to sketch a normal curve. So it doesn't have to be perfect, just draw a little bell curve, and you're going to start cutting up that curve into different lines or different areas. So we always draw a line down the middle, and that is our mean. One line on either side, again, for 1 standard deviation, another line for 2 standard deviations, and your last partition for 3 standard deviations. So you'll notice I have the mean marked here. What we're gonna do next is we're gonna label all of these other values so we know at what point is our data 1 standard deviation below or 1 standard deviation above, and then it will make these questions a little bit easier to answer. So we know that the mean plus 1 standard deviation would be 170 plus 30 is 200. The next one would be 2 standard deviations above, so 170 plus 2 standard deviations, or we could just add 30 to the previous one to get 230. Our next one would be our mean plus 3 standard deviations, which would be 260. So you'll see that I have each of those values labeled now on my normal curve. Now I'm going to go ahead and work on the values that are below our mean. So 1 standard deviation below, we're now going to subtract a standard deviation from our mean. So that will be 140. Then we'll have 2 standard deviations below, which will be 110, and then 3 standard deviations below will be 80. So now that we have our normal curve all ready to go, we can start answering questions about the different areas or the different probabilities on this distribution. So using the 68, 95, 99, 7 rule, we're going to approximate some probabilities. So we want to find the probability that the randomly selected 14-year-old boy is less than the cholesterol is less than 140 milligrams per deciliter. So what I do is when I solve these problems is I shade my normal curve, and then it helps me to figure out what areas or what percents I need to add to get my answer. So if I shade that, I know it's going to be 140 and I want it less than. So I'm going to shade it all the values that are below 140. So I have that shaded here, and then I can use my 68, 95, 99, 7 rule to identify the percents that go with those areas. So I know that will be 13.5% plus 2.35% plus 0.15%. So the probability that the cholesterol level is less than 140 milligrams per deciliter is 16%. So about 16% of 14-year-old boys have a cholesterol level that is less than 140 milligrams per deciliter. All right, so now we have one where the probability, we want to find the probability that's between two values. So we want between 200 and 260. So we're talking about these two areas here. So I'm going to go ahead and shade those. And now, just like before, I can find the areas of those two portions on my normal distribution. So I know that this portion here between 1 and 2 standard deviations above is 13.5%. And then I'm going to add the next area over, which is 2.35%. So again, I used those two areas because those were the values that I was given, between 200 and 260. So 200 is my lowest point and 260 is my highest point. So if I add those percents together, I get the probability. The probability if the cholesterol level is between 200 and 260%, or I'm sorry, milligrams per deciliter for our cholesterol, would be about 15.8% of our data. All right, our next example wants us to find the probability that his cholesterol level is going to be above 140 milligrams per deciliter. So again, same thing, I find 140, and now I want all of those values that are above that. So I'm gonna shade everything to the right of 140, even this little sliver of data over here. And then I will use my 68, 95, 99, 7 rule to add the correct areas together. So I know that since I'm using this whole area that is one standard deviation away, I can use 68%, and then I'll add my 13.5, then I'll add my 2.35, and then I'll add my 0.15 to get all of the areas that are above that 140 milligrams per deciliter. So the probability of a 14-year-old boy having a cholesterol level that's above 140 milligrams per deciliter would be 84%. All right, our last one, this should say part D, it says the probability that his cholesterol is at most 230 milligrams per deciliter. So now we're talking about that is a maximum cholesterol level, and we want that to be the highest. So we're talking about everything that is below that. So we're going to go ahead and find 230 on my normal distribution. And then since that is my at most, my maximum, I'm going to shade everything to the left. So now I have all of the areas that are below 230, which is quite a few to add together, but I can use my rule to make it easier. I notice that I have a lot of this is 2 standard deviations away from the mean. So I can use my 95% here, and then I can add the other 2 areas on to that 95%. So 95% plus 2.35 plus 0.15 will get me a probability of about 97.5%. If you don't like to use the 95%, you can still go ahead and add every single little slice together. You're gonna get the same answer. It just depends on what you're comfortable with. So again, we're just making sure that when we solve problems with our normal distribution, with our 68, 95, 99, 7 rule, that again, you don't have to memorize all of those values. If you know how to derive how to use the rule to find each little area of your slice, you can always on a quiz or test, draw the curve, calculate those areas and put them in if you're worried you're gonna have trouble memorizing it. So if you know how to derive it, then it's one less thing to remember. Again, it's always really helpful to sketch, label, and shade the normal distribution curve for each problem, just so you can have a visual representation of what you're doing and what area you're actually using and finding under your normal curve. And remember, the 68, 95, 99, 7 rule is your friend. It makes finding the probabilities on a normal distribution a lot easier. And again, it's just a generalization of our probability for our data. So now what I'd like you to do is go ahead and find that file in Google Classroom, and you'll be completing some practice problems. Please check your answers with the key as you go and reach out to me if you have any questions. We have our Module 23 quiz this Thursday. So if you have any questions on that content, go ahead and feel free to reach out. Otherwise, I will see you next time. Bye.